Good morning. So today we will have a lesson about chemical properties of metal and non-metal oxides with respect to acidity. What you will be able to do by the end of this lesson is to identify the difference between metals and non-metals by looking at both the physical and chemical properties. Define oxides and identify differences between metals and non-metal oxides. Relate the reactivity of metals and nonmetals to their atomic structure. Identify metals and non-metal oxide by looking at the reactants and products of chemical reactions, and find the products of chemical reactions of metals with oxygen, water, and acids. Don't worry, it may look a little bit scary, but we should be able to do these things at the end of the lesson. Before we get into the chemical properties, we will have a look at the physical properties. So try to complete this task, and so you have some images on the left hand side that can help you to remember some of these physical properties. But if you can't use the images, if the images don't tell you much about the physical properties, just try to think of what you know usually on a daily in your daily life about metals, and try to write down the physical properties that you remember. If you want to take the challenge, try to answer the question below, which is, can you relate any of these physical properties of metals to their chemical properties? So pause the video and try to answer the question. Okay, so if you manage to use these images, or just to remember yourself, you should be able to write down that metals has usually strong bonds and high boiling points. They're malleable, they're great conductors, and they're shiny and sonorous. Whereas non-metals are have lower density, usually low boiling point. They're brittle, so they can break easily. They're poor conductors, and they're dull in color. If you took the challenge, you could have said that metals have 3 electrons in their structure and the chemical structures, so these allow them to be good conductors of electricity. So now let's quickly remember what the atomic number is. So it is the number of protons in an atom of a particular element, and protons are found in the nucleus, and the atomic mass is the number of protons and neutrons usually found in an atom of a particular element. Remember, the nucleus is formed is comprised of protons and neutrons. So ask you to look at the image. So you have 2 different atoms, one is tin, one is carbon, and you can see they have different atomic numbers. So what would you say about the size of these 2 different atoms? So try to answer this question again, because this question will allow us to understand some of the chemical properties of metals and non-metals. Pause the video and try to answer. Okay. So yeah, let's quickly answer this question first. So the tin atom has a bigger atomic number, almost 10 times the atomic number of carbon, and therefore this means that it has more protons. And by having more protons, it means that it has more neutrons. And also, since the charge of an atom needs to be balanced, so the same quantity of amounts of protons correspond to an equal amount of or quantities of electrons. And therefore, the atoms of tin will be much bigger. And by being bigger, it means that the electrons on the outer shell will be much further away from the nucleus in the tin atom compared to the carbon atom. So have a look just at the periodic table, and you can see metals are found on the left hand side and non-metals are found on the right hand side. Metals are in light blue and non-metals are in yellow. Forget about metalloid, we're not looking at them at the moment. So usually atoms have a full outer shell when stable. So remember the famous octet rule. So they tends to have 8 electrons in their outer shell. And metals like sodium tend to form positive ions. It's here in the periodic table. This is because they usually have a few electrons in their outer shell, and therefore it is easier for them, for the metals, to lose them. Remember, electrons has a negative charge, so by losing electrons, an atom becomes more positive. As you can see in the diagram, the sodium atom had 1 electron in the outer shell, and since it's quite far away from the nucleus, it's easier for this atom for this electron to be lost, and therefore the sodium atom becomes a sodium ion. The same can be said about non-metals like chlorine, but in the case of non-metals, they tend to form negative ions. Here is the chlorine on the right hand side. This is because they usually have many electrons in their outer shell, and therefore it is easier for them to gain further electrons to become stable. As you can see, unlike the sodium atom, the chlorine atom has 7 electrons on their outer shell. So it is easier for them to gain enough electrons to become stable, and by gaining enough electrons, which is negative, they become negative. That's why they usually becomes negative ions. But remember, not always form negative ions. Sometimes they don't form ions at all. So if you've struggled to follow so far, just pause the video and maybe use the slides that you have in Google Classroom and click on the link below and watch the 2 minutes of the video. It will clarify what we've been said so far. It's been said so far. So now pause the video and try to solve these quiz. Just be mindful with the wording of the sentences and try to establish if they are true or false sentences. So metals are found on the left side of the periodic table, whereas non-metals on the right. That's true. Metals form negative ions when they react with other substances. That's false. We just seen, for example, the sodium atom that has 1 electron in the outer shell and it tends to lose it, becoming positive ion. Non-metals always form negative ions. Not as false, because they don't always form negative ions. Sometimes they don't form ions. But yes, they do form negative ions. It's just that it's not always. That's why I said mind the wording. Atoms that have more shells tend to be more reactive. And that's true, because the electrons are furthest away from the nucleus, and therefore it's easier for the atom to lose it. The core, the nucleus, which has a positive charge, finding more difficult to hold the electron. So now watch this short video, last 4 minutes, and then try to answer the following question: why the reactivity of metals increases down the group, whereas the reactivity of non-metals decreases down the group. We're talking about the periodic table. So pause the video, watch that video, and try to answer the question. So now that we talk about metals and non-metals, their chemical properties, we need to understand what metal and non-metal oxides are. So an oxide is the compound of oxygen and with one or more elements. Both metals and non-metals react with oxygen in different chemical reactions depending on their activity. So metal oxide are simply a metal combined with oxygen, and non-metal oxides are simply non-metals combined with oxygen. And examples, you can see them. They've got, for example, lithium oxide, magnesium oxide, calcium oxide for metals, and carbon dioxide, nitrogen oxide, and chlorine oxide for non-metals. So metal oxides and non-metal oxides differ in the way they react with water. So metal oxides tend to form basic solutions. Like, for example, in the example you have sodium oxide reacting with water, and then you have sodium hydroxide. And on the other hand, you have carbon dioxide combined with water to have acid carboxylic, so which is acid rain eventually. So, and has a pH that is below 5.6. So these are examples of reaction of metal oxide and non-metal oxides with water. So remember, metal oxides form basic solution from water, and non-metal oxide from acidic solutions. So now try to answer the question. So the element thallium forms an oxide, so which is thallium oxide. Thallium oxide does not dissolve in water, but does react with acids to form thallium salts. Is thallium a metal or a non-metal? And explain your answer. So pause the video and try to answer this question. Yeah, so thallium is a metal, and this is because thallium oxide reacts with acids, so it must be a base. So remember, if you got a base reacting with acid, you usually get salt and water in the product. So only metals form oxides that are bases. So now we finished the lesson for today. So just try to complete this task. So you use the knowledge organizer to make sure you know how to complete each of the question below. And remember that metal plus oxygen gives metal oxide. Metal plus water is metal hydroxide plus hydrogen. And metals plus acid gives us metal salt plus hydrogen. So and the knowledge organizer is the next slide. So and if you feel confident, try to also write down the corresponding formula equation for each word equation and try to balance them. So that's it for today. Hope you have a nice rest of the day. Thank you.